Hi, Assalamu alaikum. Alright, let's continue example number 20. Find the volume of the solid formed when the area bounded by the curve y equal to 0, y equals to 2, and the y-axis, and the rotation, full rotation, about y-axis. Okay, now again, let's sketch the graph. Now we are looking at third function. So x minus 2 is always greater than 0. So x is always greater than 2. So our graph will be the area where x is always greater than or equal to 2. Let's say here is x equals to 2. So now our graph will look like this. Right? Now we draw a line for the next condition, y equals to 0 here, and also we have y equals to 2, let's say here. Now let's identify the area. So the area bounded by the curve and y equals to 0, y equals to 2, and also the y-axis. So from here we know that the area is in here. And again, the rotation is about the y-axis. Write the formula first. Since it's rotation about y-axis, we use dy, and our subject will be x squared. So let's find the value of a and b first. A and b, as you can see here, we already have y equals to 0 and y equals to 2. And now, let's find out what is function x. Since our function is y equals to square root x minus 2, we have to rearrange so that x will be your subject. Y squared equals to x minus 2, so x equals to y squared plus 2. Now we are going to substitute the information that we already have. So a is 0, b is 2, and our x is y squared plus 2. Don't forget the squared. Now we are going to expand. We will get y to the power 4 plus 4y squared plus 4 dy. Now we can integrate them. We will get y to the 5 over 5, 4y cubed over 3 plus 4y. Now we are going to substitute the values of 2 and 0. The substitution 0 in here and here and here, as you can see, we will get 0. Now let's finalize our answer. Alright, now example 21. Compute the volume of the solid formed by revolving the region bounded by y equals to cubic function x cubed plus 2, y equals to 0, y equals to 3, and y-axis through 360 degree about y-axis. Again, let's sketch the graph. Here is plus 2 is your y-intercept. Here is 2. The graph will look like this. Now we draw the line that we have here, y equals to 0, and also we have y equals to 3. Now let's highlight the boundary. So the curve and y equals to 0 and y equals to 3, and also we have y-axis. So there are two areas here. Alright, how about now you stop writing and listen first, because there is something that might catch your attention here. So VA, the volume for area A, is pi A to B and dy So x squared as a subject. Now let's find the value of a and b. A start here and end with this line, which is 2. And we don't have x as a subject, so we need to rearrange our function y equals to x cubed plus 2. Rearrange so that x as a subject. Then you will get x equals to y minus 2 to the power of 1 over 3. So now pi, a is 0 and b is 2, and x is y minus 2 to the power of 1 over 3 to the power of 2 dy. Find the volume of b. Again, pi, we are going to use different unknown, c and d. So x squared dy. Let's find the value for c and d. Starting line for area b is here from 2, and the ending line for area b stops at 3. Pi integral of the limit start from 2 to 3, and your x is the same as before. If you still remember from previous lesson on finding the area, if you have two areas, you have to split them and calculate the area for both of them and add them up together to get the total area. If you can see here, we can follow the properties of integration. Here we have a function which is the same as this function. If we follow these properties, we can apply to this type of question, which is the total volume will be pi 0 to 3 and the same function. Alright, let's integrate this function. So we now have y minus 2 and then plus 1, we will get 5 over 3 over 5 over 3, and we are going to substitute 3 and 0. And you will get 2.505 pi unit cube.